All right, guys, we are on day 2 of graphing quadratics in Vertex form. So yesterday in the notes, I had gone over the Vertex form of a quadratic equation, which is a times x minus h squared plus k. So that is the Vertex form there. And today we're going to review graphing that. However, I'm going to show you another option as far as getting those extra points on there besides doing the just plug a number in for x method. So you can still do it that way if you want to. I'm just going to show you the graphing pattern today, and the pattern will be your a value times 1, 3, 5. It's just odd numbers. So that's an option too. Okay, so basically what you need to find when you look at this is you're going to find your A value, your H value, your K value, and those are the 3 numbers that you need to figure out the vertex, the axis of symmetry, and then plot the rest of your points, and also know if it's a min or a max for your vertex. So first of all, let's start out our first problem. So the first thing I like to do is just write down what is my A value here. It's positive 1 since we don't see anything in front of the parenthesis. My h is the number being subtracted from the x, so it's always the opposite sign of what you see there in that simplified problem. So since I see a minus 1, I'm going to make it just a 1. And then the k value, you keep the sign that you see, so that's just going to be a 2. So your vertex, which is your h and your k, is 1, 2. Your axis of symmetry is going to be x equals whatever that h value is, which in this case is 1. Now make sure you don't just write 1, it's wrong. It has to be an equation in the form x equals because it's an equation for a vertical line. It's a linear equation. If you just write 1, that's not an equation, it's wrong. Now, because the a value was positive, that means this graph will open upward, making that vertex there a minimum. Okay, so we know this one's going to be a minimum. Now, first thing we're going to do, plot our vertex, right? So we're going to go plot that 1, 2 over 1 up 2. We're going to draw that axis of symmetry. And now we want to get a couple points. So yesterday we took a value for x, we plugged it in, we got y, and then we just plotted the matching point across the axis of symmetry. And you can still do it that way. It's completely fine. But a little shortcut that I've learned is that if you take the a value and you multiply it by the numbers 1, 3, 5, usually that's quite enough to fit your graph. If you needed more numbers, you would just do 7, 9, and so on. So if my a value is a 1, and you're kind of like distributing it to these numbers, you're just multiplying them all by 1, which isn't going to change them, right? It's 1, 3, 5. So this is kind of like your rise. So if you remember rise over run from slope, if I go from this point, I can go up 1 over 1, make a point. Then I would go up 3 over 1, make a point. And if I could fit it, I would go up 5 over 1 and make a point, but I'm out of space. Then you just use your axis of symmetry to plot the ones on the other side. So I have 1 box away here, so I'm going to make 1 there. 2 boxes to the right, so now 2 boxes to the left. And then I complete my parabola. So let's take a look at number 2. So number 2, my a value this time is positive 2, so it's going to open up, making my vertex a minimum again. My h value is going to be positive 2, and my k value will be positive 5. So my vertex is 2, 5. My axis of symmetry is x equals 2. Remember, guys, it's not just regular old 2. That would mean nothing. It has to be x equals 2. And then I'm going to do 2 times 1, 3, 5 to get that graphing pattern, which is going to give me 2, 6, and 10. So now to put this all on the graph, we start with the vertex. So over 2 up, 1, 2, 3, 4, 5. That's my vertex point. Then you can draw your axis of symmetry right through that point. And now I'm going to use this graphing pattern to make a couple more points on my quadratic graph. So since I have a 2, I'm going to go up 2, and you always go over 1. Then I would go up 6 over 1, but I don't have any more space, so I'm not really going to worry about it. I'm just going to use my axis of symmetry to go up over to the symmetrical box there on the other side, the reflection on the other side of that. And that is my quadratic graph. And then if you remember from yesterday, the domain is always going to be all real numbers for these graphs. Okay, and then the range is your y values. So since this graph's opening up, my range, all the y values are greater than or equal to this minimum y value here, which is the 5. If I were doing the domain and range for graph 1, I'd have all real numbers for my domain, and my range again would be y is greater than or equal to, and that y value of the vertex is 2. All right, so let's do a couple more so we can practice graphing and using this pattern. Okay, so 3 and 4. So for number 3, my A is -3 this time, which means it's going to open down, making the vertex a maximum. My H is going to be -7, and my K is going to be -8. So that's going to make my vertex H and K -7, -8. And my axis of symmetry, x equals -7. When I do my graphing pattern, I'm going to take that -3 and multiply it to 1, 3, and 5, giving me -1, -9, and -15. So now let's graph it. So first I'm going to plot my vertex, which is -7 and -8. So -7, -8. Draw the axis of symmetry. Now I'm going to go down 3 this time because my rise, if you think about rise over run like a slope, my rise is -3. So from the vertex, I'm going to go down 3, always over 1. Then I would go down 9 over 1, down 15 over 1, but I don't have any more space. So I'm just going to do that one point. From the vertex down 3 over 1 on the other side should be that symmetrical point on the other side of the axis of symmetry. And there is my parabola. The domain is what, everyone? That's right, all real numbers. That is going to be the same every single time. And my range is going to be y is less than or equal to, because it's going downward, it's going to be less than or equal to this -8. That's our y value there. Okay, so let's take a look at number 4. So for number 4, my A is +1 again, meaning it's going to open up and my vertex will be a minimum. My H is +5 and my K is -3. So that would make my vertex, my HK, +5, -3. And the axis of symmetry is x equals 5. When I do my graphing pattern, 1 times 1, 3, 5 will just be 1, 3, and 5 for those rises when I graph. So now I'm going to graph my vertex, which is 5, -3. So over 5, down 3, make my vertex point, draw the axis of symmetry, that vertical line going through that vertex point, and now I want to use those A times 1, 3, 5 values. We got 1, 3, and 5, and they're positive, so I'm going to go up 1, always over 1. Then I would go up 1, 2, 3 over 1. You just keep moving from the point you're at. Then up 5, 1, 2, 3, 4, 5 over 1. Then just use your axis of symmetry to make the points that correspond on the opposite side of the axis of symmetry. Our domain, all real numbers. The range, since this one's opening up, y is greater than or equal to, and then the y value of my vertex, which was -3. All right, so hopefully it's starting to click. All right, so we got 2 more graphing problems. So for number 5, A is -1, which means the parabola is going to open down and my vertex will be a maximum. H is +1, opposite sign of what we see, and K is +4, we keep the sign we see. The vertex is 1, 4. The axis of symmetry is x equals the H value, which is +1. And then we're going to use that -1, A value. We're going to multiply it times 1, 3, and 5 to get the number of boxes that we're going to rise in between plotting the next point. So the vertex, 1, 4, starting over 1, up 1, 2, 3, 4. Axis of symmetry going through. Now from the vertex, we're going to use those points from that 1, 3, 5, right? Down 1 because it's a negative, and then I go over 1. From that point, down 3 because it's a negative, over 1. From that point, down 1, 2, 3, 4, 5, over 1. Use your axis of symmetry to match up points on the opposite side. And then you can draw your parabola through all those points. Domain, all real numbers, which I'm going to start writing the symbol for that. Range, y is less than or equal to the y value of the vertex, which is 4. Okay, so let's take a look at the last one here, the last graph. So number 6, my a value is positive 2, which means it will open up, and my vertex will be a minimum. My h value is negative 1, and my k value, there is not 1 there, so that means it's 0. So my vertex is negative 1, 0. My axis of symmetry is x equals negative 1, and then I'm going to use 2 times 1, 3, 5 to get my graphing points 2, 6, and 10. So starting the graph, you always start with the vertex, which is negative 1, 0. You do your axis of symmetry going through that point. And now I'm going to use the 2, 6, 10 to make my other point. So from my vertex, it's a positive 2. So I'm going to go up 2, and you always go over 1 to the side. From that point, don't go back to the vertex. Stay at where you are. And now you're going to go up 6. 1, 2, 3, 4, 5, 6 over 1. Now match up. I can't fit 10, obviously, so I'm going to match up across the axis of symmetry, the corresponding point there. It's almost like it's looking in a mirror. And then you draw your parabola. Domain, all real numbers. That's my fancy symbol. Range, y has to be greater than or all the points on here are greater than or equal to this minimum vertex here, and the y value on that is 0. All right, so hopefully that helps clarify how to do the graphing. So now the next 3 problems, we're just going to go in reverse. So again, just as a little refresher, the equation is a times x minus h squared plus k, right? So that's our vertex form. So we need to put our answers in that form. Let's see if I can fix that for a second. And so we're just going to get the information off the graph. So the h and the k is the first thing you want to get off the graph, which is fairly simple if you can identify the vertex, but the a value can be a little tricky, and that's why I showed you that graphing pattern. So the vertex for this graph here is negative 3, negative 1, right? So we know the h is negative 3, and we know the k is negative 1, but the a value, well, we know since this opens up, the a value is a positive, but like what number is it? So what you want to do is you want to go over one box and find that point. Now, how far did you have to go up before you could go over 1 to get to that point? So we had to go up 1 over 1, which means that a value is 1. And you can even check, because then you go over one more box. Look at this time, up 3 over 1. Then up 5 over 1. So if it's following that 1, 3, 5 pattern, you know it's just the 1. So then when you write your equation, it's y equals 1 times x minus negative 3 squared plus negative 1. Now, of course, you would want to simplify all that. So you would write y equals x plus 3 squared minus 1, because you don't need to have the double negative and you don't need the 1 in the front. So this would be your answer there. Okay, let's try number 8. So again, the vertex first, the h and the k. So you have 2, 0. So your h is 2, k is 0, and you know your a is going to be negative because it's opening down. So go over one box, find the point, go over another box and find the point. So we're going down 1 over 1, down 3 over 1. So what does that sound like? A negative 1. I mean, really, you could just check the first one and you're good from there. So now y equals -1 times x minus 2 squared. And then you could put your plus 0 at the end, but do we need plus 0 at the end? Of course not. We do not. We don't even need to put the 1 in here. We could just put the, I don't know what happened. My screen went a little buggy. Sorry about that. Where was I? Okay, yeah, you can just leave it as a negative sign like that, and then your answer would just be this here. You don't need to have the plus 0, and you could just have a negative sign without the 1 there. Okay, so now let's do the third one. So again, the first thing we want to do is identify that vertex. So this one is 0, 0. So we know the h is 0. We know the k is 0. We know it's opening up, so your a value is positive. Now, if I go over one box and I make a point there, and then I go over another box and make a point, it's a little tricky to tell. You got to be careful. You're really going up halfway over one. So that tells me my a is 1/2. So my equation would be y equals 1/2 times x minus 0 squared plus 0. Now again, as we were saying, do we need to put those zeros in there? No. So to simplify this, I'm just going to have y equals 1/2 x squared because the zeros would end up just canceling out. And that would be my equation for that one. Okay, so now let's do the word problem at the bottom. So it says a football is kicked into the air. Its height in meters after t seconds is given by h equals -4.9 t minus 2.4 squared plus 29. So before we answer these questions, let's look at this form here and look how similar it looks to vertex form. Y equals a times x minus h squared plus k. So this would mean that the vertex is h and k, right? H and k. So what is my vertex here? So it's going to be 2.4 for the h, and the k is 29. Now, if you imagine that on a graph, right, and you don't have to draw this, I'm just showing you for visual. If we went over 2 or 2.4, and then you went all the way up to 29, and we know it's a negative, so it's going to open down, right? So it's going to go something like this. Okay, this is a maximum, right? So this 29, we know the range here, all the y values have to be less than or equal to 29 because we know that's the maximum. So when it says what was the height of the football when it was kicked, well, when it was kicked from whatever spot we get over here when we plug in a 0. But let's skip that for a second. So let's go down to B. What was the maximum height of the ball? So when we see the word maximum, okay, we know we're talking about our vertex because the vertex is the maximum. Now the height is measured on the y-axis, so that's going to be 29. So we know that that's 29, and I think this was feet, meters, sorry. So the height of the ball, the highest spot it reached was 29 feet. How high was the ball after 2 seconds? Now, these are where we're going to plug in like numbers. X equals 2. For here, when it was kicked, that would be x equals 0. So we can plug those numbers in and do that. And then the last part says, was the ball still in the air after 5 seconds? So then you're going to do x equals 5 and see what you get. So let's try those. So if I put in a 0 for my t, for time, -2.4 squared. So I'm just going to do this on my calculator here. -2.4 squared times -4.9 plus 29. Oh, wait, I messed up. Sorry. -2.4 squared. You get 5.76. And I have to multiply that to the -4.9 in the front. And then I'm going to add 29 to that, giving me a height of 0.776 meters, which kind of makes sense because, so maybe they're holding the football a little bit off the ground, or it's on some kind of a little stand or something like that when they kick it. Okay, how high was the ball after 2 seconds? So we would be putting a 2 in over here where that T is. So on my calculator, I'm going to do negative 4.9 parenthesis 2 minus 2.4, close the parenthesis, raise it to the second power. 2 minus 2.4. And then we are adding 29 to that. So after 2 seconds, it was 28.216 meters, which makes sense. It's almost at the height because the height was achieved at 2.4 seconds, which we found from the Vertex. And then was the ball still in the air after 5 seconds? So if I put in a 5 here now into my T, and just do it on your calculator, so negative 4.9 parenthesis, 5 minus 2.4, close your parentheses, square it, plus 29, you end up with a negative 4.124. So the ground would be at level 0. So no, it was not in the air still at 5 seconds. Okay, so if you have any questions, make sure you contact either myself or Mr. K through Remind or email or whatever. And that's it. And then we will probably review this again on Friday and have a little quiz on Monday. All right, enjoy the rest of your day.